we stopped. Yeah, this equation was the last thing I remember. Transfer function we talked. If the parameters are given, how to find the time constant? T is time constant. I said there can be, you can get some problem also in the exam. I remember. That's what I think we stopped. Yeah. Yes.
Sir, can you just show us previous slides also, because
this is spring and system, spring and mass system, then spring and damper system we saw. Then this is spring mass damper system. Am I correct?
yes, sir.
This is last slide we saw. We just discussed on the it was time of week. Presentation is visible, no?
The reviewer.
Yes, sir. Yes, sir.
Okay. Good. How many students join? I think 18. Yeah.
Sir, one side back, sir, slightly. One more side. I think this is the last slide we have. Just I think so.
Okay. Fine. No issue.
Spring mass damper, sir. Last subject. Yes.
So, spring mass.
Damper. This was the last one. I still remember.
Yes.
This part I could not discuss. I just told that I discussed this.
Yes,
then I said you need to compute the time constant, which is mass by spring stiffness root. I told this, but this part I did not discuss. This part. I told up to this.
Yes,
critical damping is this one. They called a damping ratio. Delta is called damping ratio, not damping constant. The word last I told, if I remember correctly.
Yes, sir. Till that net force we have discussed, sir.
Net force and I just stopped there. Yeah, yes, you're correct. There is some problem. It is small issues there. The system was giving some issue.
Zoom is always a problem, sir, not user.
But the Zoom, no, worldwide is accepted one of the best is this one for recording everything and transmission. Quality of transmission is good.
Oh,
compared to Google Meet, because IIT also we saw only thing this fellow is asking money. Google also now asking money, but this quality of transmission is Zoom is better. That's why he's able to make money. In fact, he made a lot of profit during the Corona time.
Exactly. Correct.
Yes, sir.
Even Microsoft could not compete with him. Many government tried to ban this fellow because this actual, I think his owner is a Chinese settled in US. I don't know exactly. So this software they're getting information from worldwide, collecting and sending it to China. So they should not use also. There's a ban. Many countries did not allow official government office they cannot use Zoom. Even Indian government also initially they had this one, then they removed the restriction. But the quality of transmission, all those things is much better than anything else because I tried everything.
After that,
okay.
Sir, we can start, sir. We can start.
Yeah, 1 minute. Just 1 minute. My pen is not working. I will. Small thing. Let me close and come back. Yeah, it's working. Fine. Yeah. Shall I go ahead?
Yes, sir. Yes, sir. Please, sir.
Okay. The whole idea of the last 4-5 classes are how to model a mechanical system, starting from the basic element of mechanical system is spring and mass and damping element. As I told you many times, if I take a machine, disassemble it, individual final component like bolt, nut, connecting rod, something. Each component can be represented any one of this. It can be a spring element, mass element, damping element. If it is there, already we know that what is the transfer function mathematical model of the spring element. So here we have 3 elements already we saw. We saw there are 3 elements. One is a spring element with stiffness, a mass element with a mass M, a damping element with damping constant. Please note that this is damping constant Kd, and they are connected in series, and you are applying a force, for example, pulling, that is a tensile or compressive force. Accordingly, the spring will get compressed. In the damper, the piston will move from the current location, new location. Of course, mass will move along with this. So when I apply a force F of t as the input, already shown here, then the position of the mass element is the output. This is my output, this is my input. When I do that, how much, if I give, for example, this force is varied from 0 to 10 Newton, how much displacement from the current location? This is the current location 0 mm, correct? How many mm or how many centimeters? 0 to 20 mm it will move, or 20 centimeter. This is the output. So for that, we want to write mathematical model of the system. So mathematical model of system is nothing but describing the entire system in terms of mathematical equation. This is the mathematical model. As I told you, because this equation is a second order differential equation, this part represents the mass element transfer function or mass element model, and this part comes a damping element model. This part talks about the spring element mathematical model. For all this thing, input is same input force only we are applying. So when I apply this is the mathematical model. That means using this, even without making this physical element, I can find out if I apply a force, if the input is varied, how much output will come. X of t is the output. That I can find using computer. This is called a virtual modeling. Correct. My interest is, we know that it is this is nothing but your shock absorber. The shock absorber consists of the spring element and damping element. And previous class beginning, I told you, generally we model the vehicle when I want to design a suspension system or a shock absorber. It consists of 2 elements, one spring element and one damping element. Together, it called as a shock absorber in any vehicle, motorcycle, car, all those things. You need 2 elements. The spring has a stiffness. That's what we are modeling here. Now it is connected in series. Sometimes actually it can be connected in this fashion also. This is connected to your wheel. Correct. This is your wheel. And so this is the shock absorber. And this is the vehicle mass, which is called a sprung mass. Already I talked about it, is called sprung mass because this is suspended above the shock absorber. Shock absorber 2 elements connected in parallelly. The one end of the damper and the spring is connected to the vehicle. As I told you, if I take a vehicle, this is my engine, correct? You have seats, back seat, front seat, and you have trunk, correct? The transmission, gearbox, all those things, the passenger sitting, all those things are together is supported by a beam, correct? We call it a chassis. Chassis is the on which all these things are installed. Gearbox, everything is assembled. And passenger seat, passenger also sitting inside. And you have trunk, boot space, whatever this is. Everything together is called as the sprung mass. Correct? If you take a vehicle, if it is 1000 kg, at least 80% of the weight, it becomes a sprung mass, or remaining mass will be connected to your individual one, spring and damper, and it is connected to wheel. You have spring and damper and connected to wheel. vehicle is moving, correct? So when the vehicle is moving, depending upon the mass of the vehicle, they're called sprung mass. That's what we are talking about, sprung mass. Now, my whole interest is I wanted to maintain the constant height, ground clearance, you call it, correct? In our automobile, you call ground clearance. That means it may be 1 feet, 1.5 feet from the diameter of wheel, then suspension system height, which is finally connected to chassis. So this height you have ground clearance. That varies. You know that ground clearance should be lower is better. Just 1 minute. Okay. So you have a sprung mass which is supported by suspension because of there is a force acting downwards, which is called normal force. Already I talked about it previously, if you would have remembered. Otherwise, anyhow, you can know that. So if the sprung mass is, for example, is 1,000 kg, that means engine together, all these things, and it is supported of 4 tires that divided by 4, each on wheel or each suspension system, 250 kg mass is acting, and multiplied by 9.81 is the force. I say normal force acting downwards equal to the mass support of individual wheel. If I think that vehicle is evenly distributed, correct? There are 4 tires, 4 wheels supporting entire mass, sprung mass. That will divide by 4, multiplied by 9.81 acceleration, look at the normal force. Now that is acting downwards. Then ground will give you equal amount of reverse force, which is called ground reaction force. Ground reaction force will be equal to normal force. That's why tire will be vehicle is staying on the road. Otherwise, vehicle will sink. Correct? If ground doesn't give the equal amount of this one, and that is less force, then what will happen? Vehicle will sink inside. That's why if you try to drive your vehicle over water, water cannot give the equal amount of it. That's why vehicle sinks. But that's why hard ground is needed. If it is soft ground, correct? Sand means wheel goes to, because reaction force given by sand, and this loose sand cannot give equal amount of force. That also, if the force become more and more, if the vehicle mass is more, the vehicle will sink more inside the sand. That already we know that. So that is not our interest, but right now we want to understand what it is. Now that we know that, now if I wanted to design my suspension, there are 2 parameters we need to change. One is called damping constant damper, other is spring stiffness. Already I know that my vehicle weight is already designed, engine size, engine power, all these things the company has decided, correct? This much power, this much acceleration needed. So for that, already they made engine. Engine weights are 200 kg. The body another 150 kg. Seats, transmission, like that, everything they add up. The sprung mass already designed 1,000 kg. You can't do anything. For this, you have to design a suspension which will make the vehicle to remain at the same height. Correct? I said from the ground, the vehicle should be maintained at a particular height. Correct? We call ground clearance. The height has to be maintained irrespective of the road profile. Even if you get a speed breaker or get a pothole, the vehicle should move with the same speed. It should move with, when moving this one, height should be maintained. When you go over this one, the ground reaction force increases. That depends upon forward velocity V, correct? And the slope of the speed breaker. These 2 parameters decide what is the excess ground reaction force coming. When the vehicle goes over a speed breaker or a pothole, the wheel will go inside, or it climbs up. When it comes vertical, will be more than the normal force when the vehicle is going the flat surface. In that case, what will happen? The height will reduce because the spring Correct? If you don't have a spring and suspension with shock absorber, the vehicle will be thrown up. Automatically, the passenger inside also be thrown up. That's why you go in a cycle, near speed bump, you will be thrown up. But if you have a motorcycle, you have the suspension which absorb the energy. The ground reaction force, FG, will be absorbed. The energy supply will be absorbed by the shock absorber. That's why it called shock absorber, spring and damper. That's what the system we are talking here. Now in this system, we know that the main thing what you have to do now, please take down the formula derivation. Correct? Spring mass damper system, derive the mathematical model, find the transfer function. That means you need to write this equation. This is called time domain equation. From this, you have to write the Laplace domain equation. This is a time domain equation that is converted to Laplace domain equation. Then from that you can find the transfer function is nothing but output divided by input. That there, this is a final transfer function. In this, there are the three parameters. So this one, these are called M, K, and KD are called system parameters. System parameters depends upon the what components are there in the system. This system has three components. The system parameters: spring stiffness, the sprung mass, and the damping constant. You can see the transfer function consists only of that, nothing more than, correct? So 1 divided by K, where the K is the stiffness, or Ks we can write, and then divided by M divided by K, mass, and sprung mass divided by Ks, plus these are the variables, but that we can find out what is called, actually this is nothing but X of T. This is X of T displacement, correct? This is d by dt of X of T. This is velocity, sprung mass velocity, and this is sprung mass acceleration. Correct? This is the acceleration, A of T, I can say. This is the displacement. How much the body is moved up when it goes over a bump or goes to a pothole downward. Correct? Both way it can act. That is what it is. So these three are called output parameter. Displacement, velocity, and acceleration of the sprung mass here is our output. Once you know velocity, displacement, you can find velocity by differentiating. Double differentiation, if you do, automatically you get acceleration. So that's what in the figure what we are seeing is input is the force. Okay, so input is the force and the displacement the output. So that's what we have to find it. If you are asked to find out time constant, see the problem, you may be given mass, spring stiffness, and damping constant KD. Correct? Then you need to find the transfer function. So that means what you get in terms of 1 by K into first you will get. Then if I say K equal to 100, correct? And M equal to 1000, correct? KD equal to say 200. Then you need to, that means you have to substitute this value in this equation. Correct? So you can find the equation. So where you can find out, actually the values are given here. What is T? T is called time constant of system that you can compute. You may be asked to find what is time constant of this particular spring mass damper system. So find out the time constant. This is called time constant of the entire system. Similarly, delta is called a damping ratio. It is not called damping constant. It is called as damping ratio. Sorry, some small issues there. Visible now?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Yeah. Okay. So this is called a damping ratio. This is called damping ratio, not damping constant. Damping constant is the property of the damper that will be given by manufacturer, or you can find an equation. But now damping constant is different. This is called damping ratio. Damping ratio depends upon all three parameters. You can see here, damping ratio KD divided by CC. CC equal to root of 4 MK. Mass of the system, sprung mass, stiffness, and also the damper constant, damping constant, damper. All those things going to decide. This is what you will be asked to compute this, and compute this, and find out the transfer function. You substitute, still you will get in terms of, say for example, K equal to this much. I say K equal to, I said 100, correct? Then T means M equal to 1000. K equal to this one. The KD equal to say for example, I said 50 or something, then you can substitute in this equation. T already we know, T equal to root of m by this one. I will substitute here with 100 and here I will substitute with the K. Sorry. Yeah, first is this is 1000. Right? This is 100 and you will find T. And then T square you find out, you can substitute here. This variable remain as it is. You will get in terms of 1 divided by K, this will become a 1 value. K equal to already we are given the value 100. 1 divided by 100 is going to be 0.01. Okay, divided by the T square you will compute. Delta you can compute using this using this formula you can compute. To find out, first you have to find CC. Find out CC, find the delta. One delta, then find out T. Then you can write here, this equal transfer function you can write. So that's how you'll be asked to do in the exam. Derive and find the values. Draw the function. This is called line sketch of a spring mass damper system. Derive the transfer function. To that you start with this. Then find the Laplace. Then find the transfer function. Then values are given. You can compute this one. T you can find out. Delta you can find out. CC you can find out. From that, then you can substitute all these things here. In this equation, you'll get finally GS in terms of values, except this one. S square, maybe 10S square plus say 20S plus 1, top maybe 0.01. That will be a G of S. That's how we get it. Okay. So that's how you have to do. Okay. Next. We see in mechanical system, we saw this one. Another system, what we are going to is what we call as a torsion bar. This is another mechanical system we can see. Torsion bar consists of a rod on which at the end of the torsion bar, you attach a disc, a solid disc. This is a solid disc. It is attached to a shaft. The shaft has a stiffness K, correct? And this has the inertia I. Because here we are going to apply a rotational force. We apply torque because of it will have an inertia, then there will be an angle of twist. Angle of twist is the output. I give a torque as an input. So for this system, if I want to write the transfer mathematical model for this is called torsion bar, the T is the input, torque input equal to K into theta T, where K is called the torsional stiffness. Okay, so once you know this torsion, then I can write the transfer function, which is nothing but G of S equal to output. How much if I apply torque, correct? How much the twist will happen degree? Because one end is fixed and I'm applying a force. That means the solid torque can twist some extent. If you give too much, it will break. Correct? It will because of the shear. But up to some extent, if you apply this one, if you leave the force, you will come to original. Correct? I can apply the theta. Correct? By applying force, I can get theta made 0 to 10 degree. Correct? It can go to this one by when I apply 0 to 10 Newton meter. So this is the output, my input. The output depends upon the torsional stiffness, that depends upon the stiffness of the rod and also the mass together called torsional stiffness. So the transfer function is 1 by K. So this is, so when I want to represent the system as a control system, I will not draw all those things. I said torsion bar means I will write the transfer function, draw a box and inside that a G of S equal to transfer function 1 by K, where K is called as torsional stiffness. If you know the torsional stiffness, automatically you find the transfer function. So this is how you can model. This is another example for rotating system. Okay, another one what I want to talk about, torsional damper. Torsional damper is like a damper, and it's a piston type damper. And I think previous class we talked about piston type damper, correct?
Sir.
Yes, sir.
Sir.
Right. So this is a piston.
Yes, air piston type damper, sir. Talked about.
Oil type it up.
Oil also, sir. Air also you have.
Air can be anything, nothing but a piston moving inside a closed cylinder with a small gap on the periphery. Correct. These are the gap, and this is filled with oil. I call this one. If piston input force is given, correct. The fluid from this will come here. Then only piston could go, because we are filled with the oil. Correct. It's incompressible. Air also compressor. You can compress only some extent. After that, the fluid from this to rate at velocity of fluid moving from chamber A to chamber B. When piston is moving like this, or when moving like this, from B to A to go. Correct? That depends upon this RFI size, the viscosity, and also area. Already equation, all those things already I talk, if I remember correctly. Correct? You can get some example in exam, some problems. Find out what is damping force it created. KD. Correct? So similar, that is a linear motion. Correct? Damper the piston moving. Instead of that, I have a motor. Correct? I have a motor which is connected to this one. When I give you a force, for example, servo motor, I care that servo motor, if I give you a voltage to that, for example, 0 to 10 volts, the servo motor will rotate 0 to 360 degree. Servo motor will not rotate continuously. Generally, servo motor can particular angle you can control. My input was 0 means the shaft will rotate 0 degree. If I give 1 volt, it may move 36 degree. If I give 20 volts, like that it goes. When I give 10 volts, the servo motor will rotate 360 degree. Now, for example, sudden initially at 0 degree, I give, say, for example, 5 volts. What should happen? From 0 degree, it should 0 to 180 degree, it should rotate and stop. But when you give, the motor will rotate. Motor is a shaft as a mass moving part. It has an inertia. It has an inertia. Due to inertia, the motor cannot stop immediately, instantaneously. Correct? So if I give 180, it may go 182, or it can stop 178 also. Correct? That can be error. Or what it will do is, if I give a step input, I gave 0 to 180 degree rotate by giving, suddenly applied 5 volts at T equals 0. The T equals 0, I applied 5 volts to the motor. So the motor shaft should rotate 180 degree. But what will happen is the shaft may rotate like this. They call oscillations. Actually, it should move and stop. It should move and stop like this. But it won't, because system, the motor has an inertia. Correct? Moving part, it has a mass, and there are bearings, there are friction. Friction is there. Mass element is there, which is connected storing device. When it is rotating, when I give you electrical voltage, current flow, torque is generated. That's what move the motor shaft. That time, the moving part, what you call armature, has a mass. It has some inertia. It has stored energy. Now you stop the voltage, it won't stop immediately. It will go to 180. After that, it will oscillate also. That's what I'm showing. Correct? This is called unwanted oscillation. These oscillations are unwanted. How will you arrest it? I can put a damper. For that only I use torsional damper. Correct? Rotating motion you want to arrest, you can use torsional damper instead of linear damper. That's what is shown here. So torsional damper consists of a tank filled with a viscous fluid. This is a viscous fluid filled with it. And inside that, I have a shaft, and the shaft I have attached 4 veins. Right? The veins are immersed inside the fluid. Okay. The fluid has viscosity. Right? Now, if I give the rotational, this one force, torque, which is generated by motor, which is unwantedly oscillating, correct? It is oscillating something. The fluid friction, correct? Fluid is touching the surface, because this is going inside, there's a opposition force, correct? They're called damping force. Because the fluid is touching the surface, the amount of damping force, KD, is proportional to the surface area of the veins. Because there are 4 veins, and it has some width and height. So we can say width into height. That is the area of individual on one side. So there are 2 surfaces. Like that, there are 4 veins. So the KD is proportional to area of the veins, correct? And also viscosity also. There's a full formula. I'm not going to write that. Correct? You can find out. So that means the damping constant of the torsional damper, which can arrest this one, is proportional to area. So if I want more damping, what I can do? I can, instead of the viscosity of fluid is 10. Instead of that, I can make viscosity fluid at 20. I'm giving big number. Correct? The viscosity, if I increase, the KD will increase. Otherwise, if I increase the vein size, make a bigger veins, or add more number of veins, instead of 4, 6, the total area, we get 8 surfaces, and add together, you will get that. If you increase the number of veins, a bigger vein, then KD increases. So this is called as torsion, that is torsional damper for arresting unwanted oscillations in a rotating machines. So what is transfer function? The torque is given, correct? This is torque is the input. KD is the damping constant of the damper. As I told you, KD is proportional to area of the veins, correct? Total area plus, and also viscosity. There's a formula. the voltage dot equal to K into d by dt of theta. Theta is the angular displacement. So this is in time domain equation. Then I know generally I want to do, I convert Laplace of K Ts equal to Kd into d by dt will become S, correct? Theta will be, this is theta t, that will become theta S. So this is the mathematical model in Laplace domain. This is in time domain. Already told many times, advantage Laplace domain, the differential equation become algebraic equation, so that I can easily calculate transfer function. Transfer function nothing but output divided by input is nothing but 1 divided by Kd into S. This is the transfer function of the torsional damper. Okay. Now that we saw systems, correct? We started with mechanical system, basic element. Basic element start with spring element, mass element, damping element. We saw all those things, modeling, individual element, transfer function. This is the spring element. Then we talked about the damping element mathematical model. From that, you can transfer function already got it. Then we talked about mass element. Mass element transfer function already we have there, correct? The transfer function is this. This is the time domain equation. From that, get the Laplace. Finally, transfer output divided by input. Output is displacement divided by input force. This is 1 divided by m, where m is the mass. So from this, we have built the simple system. Then we also talked about inertia, moment of inertia, all those things if it is a rotating machine. So we found the transfer function of the moment rotating machine. Then we found the equation for this. Finally, we consolidate spring element. This is the mathematical model. K into x of t, already told you is f of t. And it is a potential energy storing. Your damper is a frictional element. The mathematical model is f of t equal to B. I told you some book they put C, in some book put the T. Don't get all are same. Different book use different notations for damping constant. It can mention small b, some book use small c, some book KD. All are same. Okay. So this model, then it is energy dissipating element. Then we saw mass element, the mathematical order m into A, where A is the acceleration, m is the mass of the element. It is a kinetic energy storing device. Okay, the transfer function already we saw. From that, we developed simple system, mechanical system. We're only having two elements, mass and spring. How to write the mathematical model, right? In time domain equation, that this can be written like this. From that, you find the Laplace transform, and then you can write output equal to transfer function multiplied by input. So this is the final transfer function in terms of this one. So that is represented like this. Then we saw about spring and damping element. This is spring and mass, here spring and damper. So time domain equation, equivalent Laplace transfer. Then this is the G of S transfer function, is output divided by input, is the final transfer function. In this system, we can see that we can find the time constant. For the spring and damper, time constant equal Kd is called as a damping constant of the damper divided by spring stiffness is the time constant of the spring and damper system. Suppose if we were given here, draw the correct sketch of a spring damper system, you have to draw this, correct? Write the time domain equation, finally derive the transfer function. When Ks is given Kd, then you can make the transfer function. And if you have to find the time constant of the spring and damper system, you can use the equation from you can find the time constant, which will be in seconds, generally in seconds. Then today we saw spring and mass damper last class. Again, to consolidate, I told you this is the spring mass damper system with 3 elements. This is the mathematical model, time domain. This is the Laplace domain. Then this is a transfer function which can be finally written like this. From this is finally, if I want to transfer function, generally make a draw a box. Inside that, you write the G of S equal to what? This represent the spring mass damper system. You can write a program in your C, MATLAB, something like the whole. This equation can be written inside this one. If I give K and M and Kd, then you can calculate Cc, you can calculate T, you can calculate damping ratio. Then all those things will be substituted. You'll get the transfer function. When transfer function is given, my output X of S equal to transfer function multiplied by input f of s. So if I give where is the input value f of t from 0 to say 100 Newton, correct? The force, what will be my displacement of the mass element? I can find out using computer program. This is called a virtual modeling or virtual simulation. Virtual modeling and simulation. What is the advantage? This is called as mechatronic way of designing system without spending money, time in making physical system. I will optimize, correct? So product will be optimized by, if I want my this displacement, if the input force is 10 Newton, correct? In the vehicle ground reaction force, F of G equal to 10 Newton, the X of T is, for example, 10 centimeter. The sprung mass goes up, correct? This will be uncomfortable for the passenger sitting inside. When I go over the speed breaker, correct? I have Mercedes-Benz car, paid 1 crore rupee. If I'm going sitting in there, my vehicle, when goes over a speed bump, my vehicle is moving over it, correct? So because of that, additional ground reaction force comes 10 Newton, correct? Or 20 Newton or even more, correct? So in that case, my vehicle is, the passenger who is sitting with along with the sprung mass will be thrown up upwards by 10 centimeter. You like it? Paying 1 crore. I said nothing doing. So that means you design a suspension system in Mercedes-Benz. What you will do? You have two options. Change the damper constant and the stiffness. Only two things. Mass of the vehicle you cannot change. Already engine, all those things decided for the Mercedes-Benz, maybe 1.5 ton. Correct? Luxury car, all those things. So that is already given. Now you will vary the KD and KS in this equation such that X of T can be, maybe it can be differ 2 centimeter. Little this one, because I paid so much money, right? So then what you do, you write this equation, the transfer function, and write a program, run the program, vary the value of KS and KD for the given sprung mass of 1500 kg for this one, and see that the output X of T is within 2 centimeter only, not 4, 5, 6. If it is too much, you will vary this the value KD and KG such that X of T output always remains within 2. When vehicle goes to 0 to 100 kilometer and goes over a speed bump, correct? The height is, for example, 10 centimeter. It has a slope something. Even if it goes there, normal vehicle, if I buy the other vehicle, pay 10 lakh only, the passenger may be thrown up, the sprung mass thrown up 10 centimeter. Here I want to maintain 20, right? So I'm giving you an example. And so if you pay 50 lakhs, it may go up to 5 centimeter. What do you do? If you're a shock absorber designer, you'll be modifying these parameters using MATLAB simulating. Once you find what is KD value, KS value for vehicle sprung mass, then you order your subcontractor who is supplying your damper. Please, I want the damping constant to be 100 only. Spring stiffness will be 50, correct? You'll say that this is what you get that and fix your vehicle over. This you are doing. This is what you do as an engineer. Okay. Then we saw about the rotational system torsion bar, how it works, what is transfer function. Then we talked about the torsional damper, correct? The transfer function already we saw. Till now we saw that. Now in your mechatronic system, you have actuators also, correct? A mechanical system will not do any work on its own. It needs power, torque, correct? We say energy, power, torque. That is generated by what you call the actuator. There are 3 types of actuators are there in mechatronic system. It can be hydraulic actuator or pneumatic actuator, or it can be electrical actuator. Next, if you see a machine, sorry, otherwise you may have engine, IC engine, or if it is a plane, it can be gas turbine. You will see any one of this hydraulic motor, pneumatic motor, or electrical motor, or engine, or a gas turbine. Only this one. But right now, these are used in bigger machines. For understanding purpose, we will stick only with hydraulic motor, pneumatic motor. But of course, the bulldozer, earth moving, mining equipment, they use big hydraulic motors, generating large power, correct? 100 kilowatt, 200 kilowatt, 500 kilowatt, because he has to move a lot of load, correct? Pushing soil, all the excavation. They are used hydraulic. Pneumatic system also in many factories are used. Electrical system actuator are widely used. So we are going to see how to model the actuators. That's what we are going to see today and tomorrow. So when I talk about hydraulic motor, this picture shows hydraulic motor. Hydraulic motor works with the pressurized fluid. It uses pressurized fluid energy source. Use as a energy source. Okay, so hydraulic motor has an inlet. They call inlet port. To inlet port, you are going to supply a pressurized fluid at so many bar or Newton per meter square with the pressure P, so many Newton, and flow rate. How many liters of fluid going to go inside the this motor and comes out? The fluid goes inside. Inside that you have type, correct? Vane type, impeller type, the system on which the pressurized fluid hits it and makes the shaft to rotate, correct? Impeller is connected to shaft. This is your shaft. So the pressure of the fluid rotates the impeller, so the shaft rotates. If I connect my load also rotates. So this is how it works. So I give in pressurized fluid at particular flow rate. The pressure will, some amount of pressure will be used for and is converted into the torque and speed. Correct? The output of the shaft, speed, and the torque generated, this is going to drive the load. So the output is torque and speed, input is pressure and flow rate. And finally this comes out. Now if I want to model this hydraulic motor, because when I want to develop a machine, I told you the mechatronics system, main thing using computer for modeling, and this one. We saw modeling mechanical system alone. Now the mechanical system is driven by the hydraulic motor, for example. So this model also need, then only I can model entire machine and find out how it works, modify the motor, each and every component in computer itself for virtual modeling and virtual optimization, correct, using simulation softwares. So that means we have to make. So that means we have to write the mathematical equation of this motor. There are two equations, right, in time domain. One is called flow, input output characteristics in terms of flow, and the d by dt of theta, which is nothing but omega. Okay, so that's what is here. So Q is input, K is called as motor constant. Note down. Motor constant depends upon impeller mass, what is impeller size, the many parameters that is given by manufacturer. Right now, that's not our interest. We need to just model. So if you buy a motor, the motor manufacturer will give what you call a motor constant KQ. That is called flow rate constant. The Q represents flow rate constant manufacturer. Once that is known, you can write the mathematical model of the system in terms of flow rate versus output. So this is input. How many liters of fluid is going, correct, per second or per minute? That is input. Then output is the speed of the shaft, that is motor speed, omega. This is the system parameter, correct? So spring mass damper system, we talked about mass is the system parameter, spring stiffness K is the system parameter, KD is the system parameter. Similar to that, in case of hydraulic motor, KQ is given as this system parameter, more manufacturer, that value is known, then automatically write the mathematical model, correct? Or mathematical model of the this one, that is this, which is nothing but the KQ remains at is W can be written as d by dt of theta, which is angular position, correct? Theta is called angular position. The W is called as angular velocity. So angular velocity nothing but d by dt of theta. That's what it is. So now this is in time domain equation. Note down, this is the time domain equation of the hydraulic motor in terms of flow rate and angular velocity. So now from a time domain, I can write Laplace. So the Q will remain as it is, KQ will remain as it is, the d by dt will become S, and the theta will become as it is, right? So generally, please note down, generally you have to write like this: Q of t equal to KQ into omega t. So this t represents time domain, which can be written as KQ into d by dt of theta t. This is time domain is Qt equal to. Now, if I convert to Laplace domain, I said Q of S equal to KQ remain as it is. the d by dt will become s, and the theta t will become theta s. And many times, instead of writing within bracket t within bracket s, people sometimes leave it. Correct? This is called a variable, but this s you cannot vary. The DDS, that's why we are written, because you may have a doubt. That's why I explain it. Correct? This s represents d by dt. You cannot miss it. But within bracket s, you can miss it. Correct? Finally, the transfer function is this. So we can write g of s is the transfer function of this motor in terms of flow rate versus displacement. Correct? So that is going to be theta divided by q equal to 1 divided by kq into s. This is the transfer function. So which can be written in terms of g of s equal to t by p equal to k. Right? So where sorry. Before that, this is in terms of angular speed or displacement versus this one, the transfer. Another transfer function you can write in terms of pressure versus torque. So the pressure versus torque is nothing but P of T. Correct? That is the pressure of the fluid. P of T equal to, I can say, KQ multiplied by T of T, where T is the output. Torque developed the motor shaft is the output, pressure is the input. Correct? Please note that there are no two quantity. Only a fluid is going. It has both the property. There's a flow rate and there's a pressure. Correct? I can write two transfer functions for hydraulic motor in terms of flow rate. Sorry, this is in terms of flow rate. This is in terms of pressure versus torque. So this is a time domain equation. Now I can get this as P of S equal to KQ into T of S. This is Laplace. From this, I can get the transfer function of the motor in terms of torque is the output, pressure is the input, then it is dependent on KQ. Correct? You can write this is the transfer function in terms of pressure versus torque. If the transfer function in terms of this one means, you will find this only. Right? Theta divided by Q. You can write two transfer function for hydraulic motor. I think time up. I will stop here. Tomorrow we'll continue this actuators. And I told you this week I want to take 2 extra classes. We missed some 2 classes. Correct?
Sir, coming Thursday, 2 hours you can take, sir.
Thursday 2 hours. That's what I one day 5 to 7 I take and close. For this week 5 hours. Okay. Tomorrow, day after, Thursday 2 hours. Then next week we'll have our regular 3 hours only. Next week.
Right,
Okay,
sir.
sir.
Right,
Okay. Thank you very much. See you tomorrow.
Thank you, sir.
Sir,
Okay. Take care.
sir,
Yeah.
sir, one question. The previous class I requested for the book to refer for the spring mast and damper system. If you can refer it, it will be helpful.
Tomorrow I will tell you. Sorry, because I was correctly on PhD thesis and MS thesis. I was totally tied up for last 5 days, day and night. So forgot. Tomorrow I will tell you the book. Okay. Definitely I will tell you tomorrow. See you.
Thank you.
No problem. Take care.